First and foremost, then the number one thing that you need to know is your midterm grade is on my LaRoche. Your grades on Canvas, not all of yours are up yet. Some of yours are, some of you aren't. So your grades on Canvas aren't updated fully. But some of you are able to see yours, some of you aren't. And that is because I didn't finish grading them all yet, at least the homeworks. And if you're curious of how your midterm grade was determined, your official one for the school, I basically looked at what you did on the midterm, and then have you submitted the homework. So it's similar. It's basically around there. It's nothing that you should be concerned about if it's lower than you expected, and it's nothing you should be like, hey, look at me, it's higher than, it is what it is. I would encourage you though, if you want to sit down and talk about stuff, I would highly encourage that you email me. We could do it on Zoom. We could sit 30 feet from each other in the library. I don't care how you want to do it. If you want to go over this test and see what you can do to do better, you got to reach out to me. So squeaky wheel gets oil, is what I'll tell you. All right, anyhow, let's look at some of these tests. And by the way, just because I hear noise, I'm going to mute you guys, but you can please talk if you want. I'm not going to be mad. Just background noise makes it tough. So here we go. Exam problems. I'm not going to go through everything in detail, but I'm going to just comment on some stuff. So the first problem, I believe, was an integral. And so was it 1B, I think? Let me pull it up, just so I'm not telling you something that's illegal. Of course that would happen. I keep getting kicked out of Canvas. Oh, by the way, did they switch all your guys' emails? Just the faculty emails. Is your email server gets okay? Good. You don't have all the issues we have there. That might be why that. Okay, so the first problem asks you to state the integration by parts formula. There's a couple of ways to think about this, or write it down, but let's just remind you that the formula says u dv equals uv minus integral v du. So I was looking for that, or I was looking for it in terms of f's and g's. I didn't care how you write it. And then, of course, the second problem, or second part of that problem, is to integrate this. And here's the thing. I'm not that I take points off for this, but there's a sure sign that I am not necessarily going to, I mean, I give you the benefit of the doubt. But there are very few people sitting in a Calc 2 class that just know this formula in their head and could tell me what this integral is without doing any work. So the moment that you don't tell me what you're picking for your u and your dv, it's not that I don't think you're, it's not that I think you're cheating. It's just that I don't, this is going to drive me nuts. It's just that it doesn't look to me like you know what you're doing. Because even if I am doing this integral, the very first thing I'm going to do is I'm going to write down somewhere, here's my u and here's my dv. I don't know many people on this planet that can do this in their head. And I didn't take points off for it, but I am, more often than not, if someone just writes down the answer, I'm assuming you got it from a computer or somewhere else. So what I'd really appreciate that you do, because it helps me assess what you know and what you don't know, is what is your u and what is your dv? And in this problem, the correct reasoning starts with let u equal the natural log of x, let dv be x to the minus 2 dx, and then your du is 1 over x dx, and your v is negative 1 over x. And then if you apply that formula, This becomes uv minus the integral v du, which becomes negative log x over x, evaluated from 1 to 2, minus the integral of v du, which is minus 1 over x times 1 over x. So this would be plus 1 over x squared dx from 1 to 2. And another thing I'd really, and this is something you will lose points on, if your arguments don't have an obvious sort of flow to them, if there's just symbols scattered all over the page, that is not good communication. Good communication is that there's an obvious flow to this. Now, you might say, well, that looks like stuff everywhere. I would agree that this is not great. But if I were writing this problem up for something like a homework assignment, or if I were writing this up on an exam or as part of a research paper or something, I would write it slightly different. But what I am doing here that's correct is that there is a clear direction with what's happening. The reader doesn't have to think about where's the next line of reasoning. The reader knows, okay, here I have an expression equals this, equals this. Now, if I wanted to be 100% complete, what I should do here is put a 1 to 2 and a 1 to a 2. And then the next thing to do is notice that this is a plus sign here because I have a negative times a negative. So now if I plug these things in, I get minus log 2 over 2. Minus a minus becomes plus the natural log of 1 over 1. And then I'll do this integral last, but I'm going to rewrite it first because it's easier for my brain. And so one of the nice things is we know that the log of 1 is equal to 0, so we can just say equals 0. And so this becomes minus the natural log of 2 over 2. Now I'm going to integrate this, and I already did this integral once, but I'll do it again because you integrate it becomes minus 1 over x from 1 to 2. And so there's a couple ways you can reason this correctly. You could say this is minus 1/2 minus 1. And so if you want, your final answer is 1/2 times the quantity 1 minus log 2. Provided I didn't make any errors. Now, maybe I did. I'm going to go back and double check. Maybe I tried to get cute with some arithmetic in my head. That often happens. I might even say, oh boy, I better go check this on the internet just to see if I know what I'm doing. Or because maybe I want some water. And nonetheless, no matter how you check it, this is correct. So the answer I'm looking for is what you see in front of you, 1/2 minus log of 2 over 2, or if you write it in this form. Does anybody have any questions about this particular problem? And then I figured, well, let's give a gift to whoever really pays attention. And if you pay attention, you could save yourself time because part C just asked, what is the area bounded by this curve? Well, you just did all the hard work. So that was like a gift. So for part C, the area is just equal to this integral. That's the interpretation, which of course is this. Does anybody have a question? So again, let me explain to you what I was talking about at the beginning. In the beginning, I said you should really, when you're doing integration by parts, it's important that you show the steps. Because there's not many people, listen to my grammar. There are not many people on the planet that can go from this starting point to down here. Now, lots of people on the planet can get that by asking a computer to integrate, but very few people are capable of doing all of this in their head. And I'm not even saying, you might say, well, how do you know I didn't do it on scratch paper? Well, that's great. If you did it on scratch paper, show it in your final solution. One of the most important things I write on this test is you'll see, you know, the very first instruction, to receive full credit, you must show all details. The goal of this class is to show that you understand calculus, that you know how to use calculus. Yes, it's great that you know how to use technology to give you answers in calculus, but that doesn't mean that that you're not doing the full thing here. So, keep that in mind. All right. Number 2, we gave you a curve, a function, and we asked you to answer a couple questions about it. So the first thing we did is we had y equals sine of x on the interval 0 to 2 pi, 0 to pi, which is a beautiful creature. What does this graph look like? Well, the sine looks like this. So the region that we are interested in is this region. And in particular, what we're doing is we're going to rotate it in 2 different ways, and we're going to obtain a solid. So if you rotate about the x-axis, the volume is the integral from 0 to pi of pi times the function squared. And we've done this integral numerous times now. So I'm not going to do it, but what you should do is you should do it. How do you do it? You take the half angle formula, and then you break it into 2 integrals, and they're not difficult integrals. And what you end up getting is a nice, pretty interesting number. It's 1/2 pi squared. So you should make sure you get that. And more importantly, I would encourage that you make sure you get it on your own. Not that you can plug it into sort of an internet or an app or whatever, but that you can do it. All right, any questions about this piece? Again, I would do that integral, but we've done it before. So it's in your notes. And then if we're going to rotate about the vertical axis or the y-axis, in this case, we use the shell method, and the volume is 0 to pi of 2 pi x sine of x. This integral we've done before. It requires parts. And I believe you get 2 pi squared. Pretty sure. But I will double check. And you do. Now, in order to save time, I'm not going to draw these or sketch these. The one, it's easy to sketch. When you rotate around the x-axis, it looks almost like a sphere. But when you rotate around the y, it's sort of like it's similar, like almost like a donut that doesn't have a hole but has like an impression, and like a bagel maybe. It's a little harder to visualize. Try to do it. Okay. Any preguntas? All right, what's the next problem? The next one is these 2 integrals. I keep hitting the wrong. Jeez. So problem 3. So we want to integrate this creature. And the correct way to do this is to break the cosine cubed into 2 pieces. So this is cosine squared, sine to the 4th times cosine x dx. And then right cosine is 1 minus sine squared. Now, I shouldn't say the correct way. This is one correct way. And so now you do a u sub. You set u equal to the sine of x. This one has a real nice answer. You end up getting, if you do it correctly, that this integral is 2 over 35. And again, you should work through this. I mean, that would be my advice to you. Work through this. If anything, it's like a good mind exercise. I like to play games. You know, do crossword puzzles, or I like to play those like puzzle games. Everybody ever play puzzle games on like a computer or your phone? I do that all the time. It's good for your brain. No different than walking a mile a day or lifting weights. Mental exercises. Integration. All right. Does anybody have a question about this? Now, again, I didn't say you have to do it this way, but this is one way of doing it. Use a u substitution. Okay, what was the next creature? The next creature was, oh yeah, the x cubed over 9 minus x squared. What a beast. So the way I would tackle this is I would set x equal to 3 sine of some new variable theta. And then dx is 3 cos theta, d theta. And then you get 27 sine cubed. And then downstairs, you get 9 minus 9 sine squared, but that just becomes, we'll take the shortcut, 9 cosine squared. And then this is times 3 cos theta, d theta. And so I believe you get 81 integral of sine cubed. I think. Is that correct? Oh, we got, no, the 3's canceled. There'll be a 3 down here in these ones, so it's 27. Thank you. Oh my God, there'd be a mutiny if you went home and said, I got that wrong. Yeah, so the 3's cancel, the cosines cancel, so you're left with sine cubed. And then integrating sine cubed, this is very similar to the previous problem. You break it into a polynomial. And at the end of the day, after more hard work, this thing should come down to, yeah, this creature. Or something equivalent. Questions, comments? You agree? Everybody agree? What's that? You got 2 square roots. Wonder who's right, you or me? We'll see what happens. Oh yeah, I mean, you could definitely rewrite it. Good exercise is to see if yours is equivalent to mine, or if you did it wrong.
I'm right.
You're right to the sine cubed, and then you're saying your expression is different than this. That's possible. And don't forget, well, okay, so here, let's see why. You know what I may have forgotten to do? You know why? Is this more like yours? I realize I forgot the 27 in there. This should be not negative a third, it should be negative 9. I'm just kidding. No, this is, I should have done. That was mean. I'm sorry. All right. I go back. All right. No. Go back. I don't mean to, I was trying to stir your imagination. That was unfair. It's negative 1/3. Now, that being said, it is possible. Look, it is always possible that the answer that you get is correct. It's just not written in the same way mine is, or the way maybe Wolfram or Mathway or one of these websites is. What I'm saying is it is possible your answer, you might think it's wrong, but it's equivalent to what I have right here. Do we understand that? Maybe, maybe not. I mean, there's lots of different ways to write this. It just depends on how you want to simplify. Okay, that being said, any other questions about this? No? Once, twice? All right, so the next problem is one of my favorites, this integral. So problem 4, we want to study this integral. And so here's the thing, we know by the fundamental theorem of calculus that this is the log of 4 minus the log of 1, and that just equals the log of 4. Why does that equal log of 4? Because we know that the log of 1 is equal to 0. The natural log of 1 is 0. So to approximate this, or to approximate log 4, we use the trapezoid and Simpson's methods. And what's important is that we wanted to use n equals 8. And that means that your delta x would be 4 minus 1 over 8, which is 3/8. Now, again, here's what's difficult, because sometimes when you're watching this or you're looking at your notes, you're like, where's he getting this from? And here's what kind of stinks from your end. I've literally now, I can't imagine, it's been probably close to 100 times since we started this in Calculus 1 that we've talked about this delta x, whether we were doing the definition of the integral, whether we were doing left Riemann sums, right Riemann sums. This is just something that, I mean, I keep bringing it back because it's something that I think is important that you understand how all this works. Okay, and then we can use Simpson's rule and trapezoid rule and all that stuff. So the next thing you do is you get, x sub 0, x sub 1, x sub 2, all the way up to x sub 8. Now, there's a few ways you can get this. I've showed you this before, how to think about it, and I'm not saying it's easy. We know x sub 0 is just the first or lower bound, that's 1, and then x sub 1 is 1 plus delta x, which in this particular case is, well, 3/8 plus 8/8 is 11/8. And by the way, it's often useful to think about 1. If you wanted, you could think of this as 8 over 8. And then you'll really see a pattern then. And then what's x sub 2? Well, x sub 2 is 1 plus 2 times delta x, which becomes, if you do the arithmetic, this is 1 plus 6/8, which is 8 and 6 is 14, so this is 14 over 8. And then you start to see the pattern. X sub 3 is going to be 17 over 8. X sub 4 is 20 over 8. And these creatures go all the way up to x sub 8, the 8th one, which is, well, what's it going to be? We know it's going to be 4. But 4 is really 32 over 8. All right, so the next thing is to say the following. What is the log of 4 approximately then? Well, we know it's this integral. And then on one hand, we know that it's approximately, what is the rule for the trapezoid? Now, you might not remember that, but it was a take-home test, and you have books and notes, and you can look it up, and we had examples where we can easily work with it. And with the trapezoid rule, it had this nice little pattern to it. Particularly, it was delta x over 2 times f evaluated at x sub 0 plus 2 times f of x sub 1 plus 2 times f of x sub 2. Now, you don't have to do all this by hand, as I said to you before. But I'll kind of go further here with it just so you can see. So this becomes 3/16. And this is f of 1 plus 2 times f of 11/8 plus 2 times f evaluated at 14/8 plus 2 times f evaluated at 29/8. And then the last one would be f evaluated at 32/8. Now, as I said many, many times before, you don't have to do this by hand. I showed you how to do it on Desmos, a quick way. You can always just plug this into a calculator. Heck, you could probably even get the internet to do it for you. You just type the question in, right? Nonetheless, I've done it for you. If you do this, what you end up getting is you get 1.397 approximately. So this right here, this is the trapezoid approximation. But you can also use Simpson's rule. So we can also log of 4 equals this, which by Simpson's rule, the formula is slightly different. It's delta x over 3. And then instead of it being all these coefficients of 2 in front, it alternates between 2 and 4. So this would be f of 1 plus 4 f of 11/8 plus 2 times f of 14/8. Oops. And then it goes all the way up. And then the last one with has a number is 4 of 29/8. And then it's f of 32/8 or 4, however you want to write it. Now, again, you could go, it's not hard to plug this into a calculator. It's easier to use Desmos or something like that. But what you end up getting is 1.386 approximately. And this is Simpson's rule. Now, what's interesting to do is note what is the value that a calculator gives you. So if I go to like Google and I just type natural log of 4 into a calculator, Simpson's rule is accurate to 3 decimal places. So if I went and I just went to the Google machine and I typed ln of 4, the Google machine tells me it's 1.386, which is exactly what Simpson gave us. So Simpson's, this right here is accurate to 3 decimal places. With Google. I will say, and I mentioned this to you guys before, it's never a bad idea. You know, if you're ever looking for an excuse to get into learning how to write simple code, this is a great exercise to learn, because it's not hard to get a computer to do this for you. It takes practice, but it's not difficult. And you know, using most most software that you can write, or what we say computational software, it would be maybe 3 or 4 lines of code. It's not difficult. And I say that honestly, you know, I never really took classes in any of that stuff. I taught myself how to do it when I was a student because I needed it. I wanted to learn how to do it. So I'd be happy to share stuff with you. I think I did. Didn't I do this with you guys before? I think I might have. Maybe I'll set up a little tutorial and I'll put it on Canvas. If anybody wants to do it for extra credit, you're more than welcome to. It's not hard. Yeah, why not? As soon as I get around to it. I mean, it won't be due like in a day. It'd be more of an excuse to give you guys a resource. I can't emphasize that enough. A skill that you guys, as scientists, I mean, I don't know what your goals are in life, but if you're majoring in science, and if you just learn a little bit of math and a little bit of how to program a computer, there are lots and lots of cool jobs that would love to have you. And a lot of them pay well. It's, you know, it's not easy to learn that stuff, but it's also a skill that's in demand. Just my 2 cents. It's pretty cool, though. You have to realize that, like many things, particularly in science, and I mean, think about it, we're always like doing experiments and we're doing measurements, and there's so much, you know, we got to approximate things, and we're trying to this theory match practice and all this stuff. And computers are such a useful tool to doing that, not just integrating. So, anyhow, enough of that. Let's move on, if we must. Well, we must. We have no choice. Okay, so the last, or no, not the last problem. Well, yeah, really it is the last problem, number 5. The other one is more, problem 6 is just like, most of you don't give it a damn thought. My favorite, you give me 1-sentence answers. Like with problem 6, like problem 8 and B. Come on. Be a brown noser, be a whatever they call it, and kiss, you know, be phony. Just give me something. Make me think you give a damn. That's all I'm asking for. Man, if this would be me, you should see the elaborate answers out there. I'd be like, my favorite problem was blah, 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 blah. It really got me in the heart. It made me so stressed out, or, you know, one of those, you know, for lack of a better word, jackass kissing sentences, you know, whatever I'm saying. All right, number 5. So this is a very difficult problem, and I tried to break it down for you. So how did you get full credit on this problem if you did? And it's not easy to get full credit. But problem A is, you think, part A, you need to understand that if you graph why is this less than 1? Well, I said look at the graph. Since 0 is less than 1 over e to the x squared is less than 1 for any value of x, you have the integral of e to the negative x squared dx is less than the integral from 0 to 1 of 1 dx, which is equal to 1. So I told you to look at the graph so that you get a hint, but that's just not enough. You got to give me a more important reason. And if you go way back to when we first learned the integral, we knew that basically this is saying that this area is less than this area. So now if you're confused about this inequality, ask yourself, I mean, look at this. This number, okay, let me be more specific. I sort of cheated because if it's negative, this for any x greater than 0. That's true. Okay, now part B was you were supposed to explain why I sub 2 is less than I sub 1. And I said draw a picture and explain, but you got to be more specific with how you explain this. You can't just say, look at the picture. Well, you can. I gave you some credit, but if you wanted full credit, you had to be more specific. So here's the observation. E to the negative x squared is less than e to the negative x. And this is true when x is greater than 1. But you should say why. And we talked about this last Thursday for those of us who were here and for those who joined in on after our technical difficulties. That you have to say something about the exponential function being increasing or decreasing, or you have to use some sort of logical reasoning, not just the picture says it is, but why. And so what this means then is this means not just that I2 is less than I sub 3, but also that the integral from 1 to n of e to the negative x squared dx must be less than the integral from 1 to n of e to the negative x dx. And this is true for, say, any n greater than 1. So it's not just true from 1 to 2. It's also true from 1 to any number. Okay, so this is, again, this is quite a difficult problem, but as I've said, it's one of the more important problems. I mean, this integral we're asking you to study is one of the most important integrals in applications of calculus. It's the basis of what we call the normal distribution in statistics and probability. So many things in your life in many ways are determined by this integral. You don't realize it. Things like interest rates on loans and premiums on insurance. And if you've ever taken a stats class, as I've mentioned, this integral is behind those z tables you looked up in the back of the book. So it is quite important. And the reason that this integral is important is that it does converge. And believe it or not, it converges to an interesting number. There's actually a pi. So maybe you guys have typed this creature into like Wolfram and you realize that this thing has pi in it. Now, we don't know how to show that in Calc 2. You got to get to Calc 3 for that fun. But we can show it converges. So this means, putting all this together, this means that the integral from 0 to n of e to the negative x squared dx can be broken into two pieces. It can be broken into the integral from 0 to 1 of e to the negative x squared plus the integral from 1 to n of e to the negative x squared dx. So the point of me asking you to draw the picture is that the key in this problem is breaking up and being able to show things. So what we can do is we now know that this guy, this piece right here, we know is less than 1. And we know this piece is less than this integral. And so using basic properties of inequalities, we can say the integral from 0 to n of e to the negative x squared dx is less than 1 plus this integral. But this integral is not difficult to compute. You just integrate. It's e to the negative x, so it's negative e to the negative x, and then you just plug the numbers in. So there's not a difficult thought process in this particular integral. So before we finish this, does anybody have a question about this particular part? Take a sip. Okay, so what is this integral? As I just said, it's minus e to the negative x, and you're integrating this from 1 to n. So if we're going to be very careful, this becomes 1 minus, you get e to the negative n minus e to the negative 1. Now, what's nice about this is this integral has very nice behavior. If we send n to infinity, so let's first clean all this up on the next page. Does anybody have a question before we do that? This is such a beautiful problem, yet it's so difficult. It's a shame. Okay, so here's what we can conclude. The integral from 0 to n of e to the negative x squared dx is less than 1 minus 1 over e to the n plus 1 over e. Someone is asking a question. About a week, Trafalgar. You get a week. So all I did is I just summarized what this previous step said. It's 1 minus this plus, because the minus of minus becomes a plus. Now, taking a limit, if we send n to infinity, the integral from 0 to infinity of e to the negative x squared dx is less than 1 minus 0 plus 1 over e, which is just 1 plus 1 over e. So we just showed that it converges. How do we know it's convergent? Because the limit exists. That's what it means. So the best we can do is we can tell you this integral from 0 to infinity converges. We can tell you it's a number, and we can tell you it's between 0 and 1 plus 1 over e. Now, in Calc 3, you actually learn the following, which is pretty darn cool. And it's worth me showing you. So in Calc 3, we learned that this integral, I don't know how the hell it happens, but it happens, is actually equal to the square root of pi over 2. Like, how in the world pi is involved, one never knows, but it is. Pi is everywhere. It's so damn magical. Isn't this fun? Look, this is a conceptually challenging problem. This is not a problem that you should get upset or disappointed if you struggle to understand it. In fact, for many people, it will take a lot of work to understand this. But it's a fair problem, in my opinion, especially on an exam I gave you, what, 3 days to do, 4 days? Now, a lot of you got partial credit, but in order to get the full credit, you have to explain these details either the way I did it or in a similar manner. And again, why this is a good question is because it's really a culmination of so many ideas we've learned since the beginning of not just calculus last semester, but even things in arithmetic. This idea of inequalities, which is a huge way we do argument in advanced mathematics. Physics uses these things all the time. So anyhow, I hope you'll try to learn about it. Thank you, guys. I will see you Thursday. Be safe. All right. Yes, sir.
Okay, sir.
That's correct. Yeah. I mean, you had the right idea.
Okay.
Yeah. And this is, I mean, you did a pretty good job at it. I wouldn't say it's perfect, but it's close.
Yeah.
Yeah. You'll see my comments on Canvas. All right. And if you want, we can meet. You and I still need to get together, right?
Yeah.
Yeah. Oh, I forgot to save this. Cancel. I did, Mohammed. I did not get a chance to respond. I will do that today. How's that sound?